This is the harmonic series. Today we are going to be doing Nicole's proof. Nicole wanted to prove that the harmonic series was divergent. And as you can see, the sum of 1 over n, as it tends to go to infinity, is as follows. 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8 plus 1/9, and so on, because it is going to infinity. So, for his proof, he started out with replacing each of these terms with one that is less than or equal to itself as a term. Now, if we go into the new series as it is divergent in the original series, and we compare them with comparison test, we will find out if it converges or diverges. So he replaced each of these terms with the power of 1/2, that is So he replaced each term with the largest power of 1/2 that is less than or equal to its term. What is the largest power of 1/2 that is less than or equal to 1? Well, that is the power of 1/2 that is 1/2 to the 0th power is 1. So if I get my next marker and I write down 1, because 1 is the largest power of 1/2 that is less than or equal to 1/2. Now, so that was the first one, and now we are going to go on to the next one. Then we will go to the next one, which is 1/2. And what is the largest number that 1/2 can go to that is less than or equal to the power of 1/2? The answer is also 1/2. And that is the 1/2 to the first power. Now, what's the largest power of 1/2 that is less than or equal to 1/3? Well, if I get my next marker, which is going to be orange, we know that 1/2 is obviously larger than 1/3, and it's not less than 1/3. So I hope you guys know that. And we want it to be less than 1/3, so the largest power of 1/2, and that is equal to or less than 1/3, is actually 1/4. So we replace 1/3 with 1/4, and then we also replace 1/4 with 1/4 as well. Now we will look at 1/5. What is the largest power of 1/2 that is less than or equal to 1/5? I'll wait for you to answer, Penner's class. Once again, 1/4 is larger than 1/5. So the largest power of 1/2 that is larger. You were right about the dogs, Megan. So the largest power of 1/2 is less than or equal to 1/5 is 1/8. Once again, 1/4 is larger than 1/5, so the largest power of 1/2 that is less than or equal to 1/5 is 1/8. So you replace that with 1/8. You, of course, would also replace 1/6 with the same reason with 1/8.
You're off.
I am.
You already wrote 1/8.
So I won't write another one.
No.
No, I need 4.
Yeah, 1 goes under 1/8. You wrote 2 for 1/5. There was already 1 written.
That's okay. Okay, I realized that I wrote it at the wrong time, but that's fine. So anyways, with 1/7, you will write a 1/8 as well. So I'm gonna call that one my 1/7. Okay, that sound good? Good, cool. And then you would do the same with 1/8 as well. And now we move on to the next term, which is 1/9. What would you replace 1/9 with? Well, as you can guess it, or maybe you can't, you would replace it with 1/16 by the same argument. And you would keep going on and on and on until you get all the way to 1/16. You would have 8 1/16 in a row if you kept going. And along with that, if you kept going after this 1/9, you would find out that it goes into 1/30 seconds. So let's confirm with the comparison test. First, each of the terms in the first original are non-negative. And then in the second series, we can see that each of these terms are also non-negative. And then we can see that each of these terms in the first series is greater than 1 or equal to in the corresponding terms in the second. So as you can see, 1/2 is equal to 1/2, 1/3 is greater than, 1/4 is same, 1/5 is greater than, 1/6 is greater than, 1/7 is greater than, 1/8 is the same, 1/9 is greater than. So then we'll call this S. So if we can prove that S diverges, then by the comparison test, the largest series will also be divergent. And how do we do that? Well, let's take these sums. This is going to be S equals to 1 plus 1/2. And then 1/4 is also 1/2. And then 1/8 plus 1/8 plus 1/8 plus 1/8 is 2/4, which is also known as 1/2. And then if we had our 8/16, that would also be 1/2. And then it just keeps going constantly. I think you see what's going on here. And I've got to say, this is pretty exciting to see that it just continues on going on 1/2. And then clearing this is unbounded and going to infinity. So we would write equals infinity. Yeah. And S means it diverges. Yeah. And since each S term is less than or equal to the corresponding original series terms, we can say that the harmonic series diverges. So then we say harmonic. Spelled that wrong, that's okay. Because they are the same. There is no way this can converge if the sum of S is smaller than each of its smaller terms and the sum goes to infinity. So the original must go to infinity as well as the sum and that sum because they are the same. And that concludes our proof.